2014 Paper 1, Question 21. This question is rather trivial when you have a graphic calculator, but we'll just go ahead and do it anyway all the same, just to show you all the core skills. We've gone to a graph page, we're typing the function as it's given to us, we see it on the screen, and we're just going to find out the locations of all of the features of this graph. If we press Menu, choose Analyze Graph, we can do minimum, maximum, and just literally find all those bits of information. The quickest way sometimes might be just do Graph Trace. And as you can see, we start off at 0, we then hit the maximum at 2, 4. We have another 0 at 3, 0. Oops, and we have another 0 at 0, 0. So if you had the calculator to hand, if you were doing a question like this, you could very quickly verify if your answers were correct. If you want to do the same sort of thing on the calculator page, if I press Control Dock to insert a calculator page, I'd be looking to find out where the stationary points are, and I can find out effectively where the first derivative is equal to 0. So if I press the template button, I have access to the first derivative. So I'll do d by dx of my function, and it just so turns out, because of the order I've done things, f1 of x contains my function. Now I'm trying to solve when this is equal to 0. When I press enter, it's going to give me an error because it doesn't know what x is. There we go. But if I now go ahead and do Menu, Algebra, Numerical Solve, and then paste that equation in and stick a x on the end, it will solve this and find the values for x where there's a stationary point. And we have a stationary point when x is 0. If we go back to the graph, that is indeed true. But we have another stationary point up there, so we need to go looking for other stationary points. So if I just paste in that statement by highlighting it and press enter, if I now press Control equals, I can then move across this vertical line. It stands for given or when, and I can then type I'm looking for x to be possibly greater than 0, so Control equals greater than 0, and it will now go ahead and find the other solutions to this inequality where the first derivative is equal to 0. Determining their nature, you could easily evaluate the derivative of this function. If I just go back up there, edit it out, if we're looking for something at 0, we could go a little bit to the left, like negative 0.1, and this will work out the derivative just to the left of 0. Oh no, that's not how we do it, my apologies. We have to have the value of x in there, and what we actually have to tag on the end is when x is equal to negative 0.1. That's just to the left of 0. There we go. And just to the right of 0, we could do a positive. So it's negative on the left, positive on the right, we have a minimum. And we could do the same process here. I could look at just to the left of the stationary point of 2, so at 1.9, the gradient is positive. Go a little bit to the right, 2.1, the derivative is negative. Alternatively, I could work out the second derivative of these. So using the template button, go for the second derivative, d by dx, d squared by dx squared, stick in f1 of x by pressing the var key, and I'm going to evaluate this at x is equal to 0, just to see what happens. I get a value of 6, so it's positive, so we have a minimum, and similarly I can evaluate it at 2, we get a negative second derivative, which means it's a maximum. So that can check any other workings you may have done algebraically. We're done.